Hello friends! I've got several things to show you today, but the main focus of this video is on how to solve the problem that you see over here. Now this SE30 has ZigZagJoe's fabulous LCD color kit installed, but under these lighting conditions, as you can see, the screen is a bit too bright. Now, on the back of the LCD, there is a brightness adjustment knob, but you're not going to open the case every single time you need to use it. Thankfully, ZigZagJoe made a convenient way to solve this problem. Have a look. Ta-da! Now, it would have been nice if the LCD color kit included this brightness potentiometer I just used to adjust the brightness, but the good news is I'm going to show you how to buy one and install it. Before we begin the brightness knob install, I want to mention three things. First, I had a 3D printed fan mount made at JLC 3DP, and I've linked the STL file for you in the video description below. That eliminates the need to remove the fan and metal mount from your stock analog board. Just buy a Noctua 60 by 25mm fan, 3D print this mount, and you're all set. Mine was printed in PA12-CF, which is a carbon fiber reinforced nylon, very strong and rigid, but not as rigid as metal, which helps this mount dampen fan vibrations. Previously, when using the metal fan mount, I was getting some bothersome noise, but when I installed the carbon fiber mount, the noise mostly vanished, so I highly recommend the 3D printed fan mount. Also, I put links to the bolts, nuts, and washers in the video description below. Next, I want to show you how I packed away my CRT, which of course you have to remove when you install the LCD color kit, for safekeeping. I put it in a very sturdy box, with lots of these air cushions all around, and of course a thick layer of bubble wrap at the very bottom where the glass is. So the glass is facing down, and the CRT yoke is facing up, and you'll notice this little red thing here. This is a really neat CRT yoke protector that I had printed at JLC in red PLA. It was originally created by Nick Gillard of 1-Bit Rainbow and later revised by Tinker Different Forum member Caver01. I put a link to the newest STL file for you in the video description. The yoke protector ensures that the fragile glass neck of your CRT won't be broken while in storage, so I highly recommend printing one of these to protect your CRT. Lastly, some of you asked if the Synchro 30S 256MB RAM card is compatible with the LCD color kit, and I can report that it does work fine in my SE30, which has a 50MHz CPU socketed Daystar power cache installed. But because I want the power cache acceleration, I have to disable the Synchro 30S's extension in order to load the Power Central Control Panel, which disables acceleration on the RAM card and reduces the RAM to only 128MB. See my Synchro 30S video for details. These are all the parts you'll need for the brightness knob install, and I'll discuss the detailed specifications of each later. The main part is the potentiometer, also known as a pot. Then we have a single strand of solid copper wire for extending the 3 legs of the pot. You'll need a 2-pin header, and 2 jumper wires that have female connectors at each end. Then you'll need a plastic knob, either one from your stock analog board, which is what this is, or a 3D printed one. I put links to everything shown here in the video description. To start your brightness knob install, locate the tiny blue brightness potentiometer here. Then insert a Phillips screwdriver and turn it as far as it'll go to the left, counterclockwise. And don't use too much pressure. Just to the left of the pot, we see a 2-pin header. Attach your jumper wire pair to that header, and note that I superglued my connectors together to better ensure that it's never going to come off. The opposite end of your jumper wires needs to connect to the tiny 2-pin header that we talked about before, and that needs to be soldered onto the analog board at this location here. We need to remove the analog board anyway to do the potentiometer install, so I'm now going to remove the analog board off camera. And when you do it, be sure to disconnect all of your cables before you yank it off. This cable up here, the black one, is especially difficult, so treat this with care when you're removing it. Now with the analog board removed, we need to take off this plastic cover. On the flip side of the analog board, we see it's held on here and here, and it looks as if I should be able to get it off with a pair of needle nose pliers, but just by squeezing and The other one. Oh, I didn't see there's a third one here under the wires. Okay. And we need to put our header in right where it says brightness. And after soldering it in and cleaning up the flux, this is how it looks on the solder side. And there it is on the connector side. Before we install our potentiometer over here, let's review ZigZagJoe's documentation. Here's ZigZagJoe's official brightness knob install guide. It says we need a 10 kilo-ohm potentiometer, and the physical requirements list 4 key things that you need to keep mindful of. But this is hard to understand until you see a data sheet, which I'll show you later. For now, just take note of the 15 millimeter shaft length. It then suggests a Born's part number with a 20 millimeter shaft, which is rather confusing. Is it 20 millimeters or 15 millimeters? Now, I spoke to ZigZagJoe about this, but the documentation still hasn't been updated as of the making of this video. Initially, I had no idea which of the 2 shaft lengths was best, so I bought this 20 millimeter shaft length pot from AliExpress, with specs similar to the Born's pot that ZigZagJoe recommends. The AliExpress pot is branded Alps Japan. Sadly, the 20 millimeter shaft length is just too long, and you can see that when compared to the pot on the stock analog board. I didn't want to mess around with cutting it and sanding it, and to be honest, I know that most of you don't want to do that either, and some of you just don't have the tools to do that. I then found the same kind of pot on Amazon Japan, but this time with a shorter 15 millimeter shaft length. And here's the size diagram that helps you make more sense of ZigZagJoe's installation guide. We see it has a 6 millimeter shaft thickness. This looks like a 5, but it's actually a 6. And the shaft length, including the threads over here, is 15 millimeters. Notice that there are no grooves or ridges on the shaft. It's smooth and round except for this little flat part right here that's 7 millimeters long. That's exactly the shape we need. There's also no shaft collar on this pot, so we're good on that. And this pot also has a linear taper, and to explain that taper better, I'll now show you the equivalent pot I found on Mouser. And here is the pot on Mouser. Just ignore this photo because Mouser often shows the wrong photo. It is in fact the correct flatted shaft type. We can look down in the specs where it says the taper is linear here. And if we look at the data sheet, we can see this very nice graph here that shows us the B taper, which is perfectly linear from this corner all the way up to the top. And that's exactly what we need. And also this particular potentiometer is an F-type, which means it's flatted. It's just like what we saw in the previous diagram, with the T section being 7 millimeters and the total length here being 15 plus minus 0.5 millimeters. The other specs, we see the resistance is 10 k ohms. It's 1 gang, which means 1 set of 3 pins. It has a 6 millimeter shaft diameter. And again, it shows here it's flatted. It's also using conductive plastic, which gives it a much longer life of 100,000 cycles. So all very good specs. And you'll find a link to this pot in the video description. Here's the pot I bought on AliExpress with a 20 millimeter shaft length that's too long. And here's the 15 millimeter shaft version that I bought on Amazon Japan, which is basically the same as the pot I just showed you on Mouser. You can see how it compares with the stock analog board's stock pot. Very comparable. You can use your stock analog board's brightness knob if you want, but I think it's better to make a 3D printed version. That way your stock analog board will be 100% intact, and then you can use it on another Mac SE or SE30 if you like. Here are all the knobs that I printed at JLC using the STL files created by Tinker Different forum member Caver01. Now, some were printed with a super thin brim around them to get around JLC's excessively strict and bothersome minimum size requirements for some filament types. The brim helped me get around those requirements and get my order submitted. I printed the knob in 3 types of plastic. The first is over here, soft and flexible TPU. And if I press on it, You can see it bends very slightly. It feels like hard rubber, actually. And the next is 100% transparent SLA 8001 resin. At least that's what JLC calls it. And then I use the same PA12-CF carbon fiber reinforced nylon to print these two knobs, just like I did with the analog board fan mount. Now I printed 2 of this type and 2 of this type because they're actually 2 STL files, and they differ based on the inner diameter. Notice that in the very center, on the bottom side of the knob, you've got this part that will slide over the shaft of your potentiometer, and one of them is 6.0 millimeters in diameter and the other is 6.2. And so I wanted to test which would be best. Now, TPU is very firm and flexible, like I said, so either 6.0 or 6.2, doesn't matter which, it will work on the shaft of your potentiometer. But when using the carbon fiber or the transparent, they're very hard plastics. So I found that I needed to use the 6.2 millimeter diameter version STL file to make it fit. TPU is kind of neat in concept, but the tip will insert into the back side of the front plastic case of the SE30, and the rubbery nature of TPU would prevent it from turning smoothly, I think. The gritty nature of my carbon fiber knobs would also hinder turning, in my opinion. And on top of that, the inner hole wasn't printed very smoothly either, requiring hand cleaning with a knife before the shaft will fit inside. And you have to cut off this brim, which isn't too hard, but still it's an extra job you'd have to do. The best knob, in my opinion, is the transparent resin, because resin allows it to be made with high precision, and there's no brim to be cut off, and it's perfectly smooth too, which means that it should turn as smoothly, if not better, than the stock knob. Another huge benefit to printing this is if you have one of the 100% transparent MacuFX cases for your SE30, your knob can now match the case. So basically, you just need to use the STL file that has a 6.2 millimeter inner diameter and no brim, and I've linked that for you in the video description. Since we're on the topic of 3D printing, I should mention that I had introduced these DeskSaver Feet before in another video, but basically you put these on the metal chassis on the bottom, and that way you can leave the back off of your SE or SE30 machine and you won't scratch up your desk. And previously I had printed these. The black ones are SLS 3201PA-F nylon. And in my recent order, when I printed the knobs, JLC had a gray nylon. It's called MJF PA12-HP nylon. And even though these are both nylon and extremely robust and also flexible, the gray is smoother to the touch. This is a little bit more gritty. So this will be even kinder to your desk, and I would recommend that you print these. All the information is in the video description. Now that we have the right pot and knob, we just need to extend the legs with the solid copper wire that I purchased. Again, this is 1.0 millimeters in diameter, roughly 18 gauge. And again, I put an Amazon USA link for you in the video description. Now, I put the, I didn't bolt it down, but I did align the holes on the back. This is a Sony power supply. And we can see that the silkscreen printed line is going further to the left than the actual power supply. So that means we actually can move the back side of the potentiometer a bit further back if needed. And we can see that ZigZagJoe drew kind of an outline, which we can see here. You can see it kind of, the edge of the pot is supposed to go about to the edge of the board. It's kind of hard to show you and hold it up at the same time. But approximately like so, which means the legs aren't going to perfectly fit. If we put the legs in the middle, you know, the legs cannot fit directly in. We have to solder on additional legs. But if the legs go down in the middle hole, this is roughly where it should be. Now, ZigZagJoe's documentation doesn't give specific guidance about lengths. And maybe that's because he didn't want to get too specific because his decision about the pot was up in the air. I'm not sure. But he suggested soldering the wire into these 3 holes here. However, that's going to make it jut out more. And what I think I'm going to do is I'm going to solder wires to the front side of each one of these pins. Longer than it needs to be, of course, because I still need to adjust. I don't know how long they need to be. But I think if I do that, I can push it back a little bit. Yeah, I think I'm going to do that. And then once I solder on those wires, leg extenders, I mean, then I can remove the power supply, put this analog board into the machine, and then we'll do a little test. So what I did here is I measured off just at random, nothing magical about the length, 2 centimeters of length for 3 wires here. I put just a very tiny bit of flux on each pin, then I put some solder on each pin, and I put a little bit of solder at the tip of each wire to make everything much easier to solder together. And this is the end result. Okay, what I did is I put the knob in through the holes. I had to shorten the wires by more than half in order to make it fit in. So I could put in the analog board, and then I put in 1 screw here and 1 screw here, because that's the exact location it's going to be. Of course, not forgetting to put the top right corner into this little plastic slot up here. And you can see I needed to shorten them quite a bit because the plastic case was in the way, but there's still enough length to let me adjust it. And here we can see that I have the knob on there, and the potentiometer is going in just very slightly at an angle. I mean, I can turn it. I'm turning it right now in my fingers. I can turn it, and there really isn't much resistance there, but it's not perfectly perpendicular with the board. You can kind of see that here, that the body is coming down a little bit too much at the far left part, and I need to think about how to adjust that. Well, I finally got it in pretty straight, and you can kind of see the copper wires there are a little bit bent out of shape. I've got the power supply in there now and the analog board mounted. I haven't soldered anything yet, and I'll remove it to show you, but you can see it's pretty good now. And here is the pot removed. You can see the legs are now kind of bent into somewhat of an S position, a curved position. I took my needle nose pliers and pinched the tips to bend them all backwards, and then after I had bent them backwards, then it's going to be not straight, it's going to be even worse. So what I had to do is I had to pinch it close to where the solder joint is here, and then I bent it back in the other way. So it's kind of a very faint S shape that you can see. And in order to pinch them all, what I did is in the same way, the tips of each wire, I just counted the teeth on the tip of my tool there to know how much to pinch the tip of each wire to keep that part straight and then bend it back. And so that's how I did it, and it's fiddly work. I really didn't want to do it, but that's really what you would have to do to make it offset enough to go back. It would be best if the PCB could be updated and the pads could be pushed back a couple millimeters so that the legs could be straight down instead of having to be bent like this, but that was the only way that I could do it to make sure that the pot is going to go in straight, meaning that the pot is perpendicular to the actual circuit board. So that's unfortunately the type of job that you're going to have to do with your own pair of needle nose pliers. You just want to make sure that you put enough solder on both the front and all around on each leg so that the solder's not going to crack or otherwise allow the legs to come off over time, and certainly not while you're bending them like this. Now, while this isn't absolutely necessary, in the past I bought some of this rubber which has 2-sided tape on it. It's 2 millimeters thick, so it's not too thick, and it might be just a little bit too thin, but I'm going to put a little bit of it onto the power supply behind the pot just to add a little extra buffer so that it won't bend the legs any. And you can see that here's the location of the rubber that I put on the power supply. So what you want to do is, once you have everything done, your rubber placed on the power supply and all of that, and you've confirmed visually that it's straight and that you can rotate it with your finger just fine with pretty much no resistance, Then you want to put in your power supply and the analog board. I screwed mine down, analog board with 2 screws, power supply, 2 screws, caddy corner, and that way everything is secured. And it's exactly as it will be when you reassemble it. And then in that condition, then you want to solder. So I'm going to do that now. I did the soldering off camera, but you can see the result here. I soldered these 2 with the analog board in place, and then I removed it and then soldered the 3rd one. And this, of course, is after I cleaned off all the flux. And here are how the joints look on the component side of the board. I did not remove any of the flux because I didn't want to accidentally bend it out of place. Note that you could add more solder on this side of the board too to make it even stronger, but that's going to reduce your ability to bend those leads in case you need to do so. Now, just to give you a few words of advice, I would recommend you get a microfiber cloth, some kind of cloth that's kind of thin. If it's too thick, it's going to get in the way. Put it over here when you do your soldering. You could probably get away with soldering 1, but I think doing 2 is better. No way you're going to get the 3rd one down there without destroying your case. So put something over it and then put a piece of foil over it. And that way it has heat deflection that is going to protect your plastic here. If you use Kapton tape only, it's not enough. The heat will go through the Kapton tape. It won't burn up the tape. It won't burn a hole through the tape, but it will melt the plastic. You know, Kapton tape is not a magic cure for everything, folks. So please be mindful of that. You're going to need a buffer of some kind. And that's why I say a cloth. And then to avoid burning your cloth, you want to have a piece of aluminum foil over it. Just something so that my soldering iron is turned off right now. But when I soldered, I mean, I was able to do it because I have years of experience. So I was able to do the first one and no burn marks. And then very, very carefully, I was able to do the second one as well. But I fear that many of you may not be able to do that. And that's why you really need to put your protection here. Because honestly, if you accidentally, let your hand fall, you're going to mar your case. And you don't want to do that. So make absolutely sure that you put adequate protections. And really, I don't think we can solder with it off the case accurately. You really need to be in there to make sure the knob is in the perfect position, and then you got to tack it down. So if you have a better way of tacking it down without soldering it, then be my guest and do that. But this was my way. I needed to tack it down with solder, and I felt that 2 joints would be the best way to do that. And then, like I said, you can take it out and then do the 3rd joint. The next step is to make sure that all of your screws, 4 screws for the power supply, 4 screws for the analog board, are all screwed down. And then you want to reconnect your power supply, reconnect the main wiring harness, and of course you've got the 2-wire connector that we have to plug in like this. And the Amazon link I gave you for these wires, the wires for that link are shorter than this one. These are just ones that I already had. And then we put back on our fiddly black connector. He's always so difficult to take off because he's a locking type. I'm thinking about cutting off the lock because I don't really like it. And of course, make sure your fan is connected. You didn't disconnect that, but just recheck all the connections there. And again, make sure that your potentiometer is set all the way counterclockwise. And here we are, ready to test the brightness knob. I have the brightness set to max right now. My camera is adjusted for the max brightness. And my camera's synchronization is also locked to the LED frequency that you're seeing here. And unfortunately, as I decrease the LED brightness, I think it's PWM, so my camera will lose sync and it will look like it's flickering. But in real life, there is no flickering when you reduce brightness. So I just want to mention that before we get started here. So what I'm going to do is just go down 1 stroke. Now 1 stroke means my finger starts at the brightness knob opening hole at the left and it goes all the way to the right. Did another one and another one and okay, and then it goes dark and I can still do 1 more. So there's not a lot at the bottom to adjust the brightness, but going back up, 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 and there's maximum brightness there. Great. Now, I also want to mention that now that it's at maximum brightness again, this is not an IPS display, which means if you look at it off angle, which is what my camera is doing now, kind of looking top down and a little bit at an angle, this area of gray, you can see it mostly in the gray background, appears to be a little bit darker than this, only because it's not IPS and you're looking at it off angle. Now, I'm actually looking at it physically with my eyes, even more off angle than you are, because you folks are looking at it through the camera. And it's a little bit darker to my eyes here, but it still looks beautiful. So, you know, as you saw in my main video about this LCD, so it's just a beautiful LCD, but now we have the brightness knob. Look at that. Now you get most of your adjustability kind of in the middle area. You can see that here, where it's actually really, really changing a lot. But then as you go up to the extremes, I can move it a lot. I'm moving it quite a lot now, but it's not a big change. And if you go all the way to the end, it's kind of abrupt on. Let's see if we can find the minimum. All right, that's the minimum brightness level. Anything lower than that, and it cuts off, which is kind of unfortunate. I wish there was a little bit more room, but still better than no brightness knob at all, right? And so it's not exactly the same as your CRT brightness knob, which is going to be linear all the way from maximum brightness until it goes off, which is the ideal. And this doesn't do that for reasons I don't understand, but it's not bad. Now, when would you have it this low? Obviously not in a well-lit room like this. No. Because if you wanted to save the screen, you'd use a screensaver, right? But the way I use it at low brightness is if I'm running Mac bench, takes hours, right? You want to go to bed at night maybe, right? Let it run for a couple hours. And but you don't want to shut off the screen because you want to wake up every now and then to kind of take a look at the screen. Is this minimum brightness level too bright for your bedroom when you have all the lights off and you're in bed sleeping? And of course, all the lights are on in this room. It's a little bit hard to gauge, but I have a lot of experience with it, and I can say it's probably a little bit brighter than you want it to be, but it's not bad. Okay? So the minimum brightness isn't bad. It's just not ideal. I wish it could go a little bit darker while still being able to see the screen, but what you see here, under these lighting conditions and camera settings anyway, is the minimum brightness that you're going to get. And then as we go up, there's the maximum. And again, you can move it a lot at the max, but it's not really changing a whole lot, and you have to move it kind of more towards the middle. And then you can see bigger differences. But hey, you know, I maxed it out now. Overall, you know, it took a little time, but folks, this is a success. Even though you have to buy all of the brightness knob parts separately from the LCD kit, and even though it'll take you at least an hour in labor to follow my lead and do what I did, I still think it's worth it. But I'd like to hear your thoughts. How many of you even own this LCD color kit? And for those of you who do, how many of you are now interested in installing a brightness knob after watching this video? Let me know down in the comments. Next, I have some good news for you Color Classic owners out there who watch my beefy component upgrade. I recently came up with a way to reduce the temperature of the extremely hot 18-volt Xenier diode by 20 degrees Celsius, which is a lot. I put a detailed report on the Tinker Different forum, and you'll find a link to this thread in the video description. It takes an extra effort to add the heat sinks that I used because you have to cut apart copper alligator clips to make them, but it's not too difficult, and I really think it's worth doing. Separately from that, I want to add that Mac SD is my preferred SD card drive in my SE30 because it offers me snappier performance, in this machine at least, than BlueSCSI version 2. But the stock metal mounting bracket covers the main wiring harness connector on the motherboard, making it really hard to remove. The thing is, I have to mount Mac SD above the floppy drive to ensure my PDS cards and rear expansion slot are free for other things. The good news is that Tinker Different forum member JMaxZ has come to the rescue with an incredible 3D printable recreation of the metal drive bracket that completely removes the bothersome backside. He also created a slimline plate for mounting Mac SD, Blue SCSI, and other similar SD card drives on top of the floppy drive. I ordered both from JLC today, and I hope to show them to you in my next video. Speaking of my next video, I plan to recap this LC520 motherboard and overclock it with an easy resistor mod. Now, some people have told me that will convert this board basically to an LC550 in terms of overall performance. The LC550 board is also used as the stock motherboard in the Color Classic 2. So stay tuned for that. If you like what you saw today, folks, please consider giving it a thumbs up, and please subscribe and click the bell icon if you'd like to receive notifications of my future videos. Thank you for watching today, and I wish all of you a fantastic week. Bye-bye.